Hi guys, Mathemagic here. Today we're going to be looking at some different science concepts in the fresh new 1.17 Caves and Cliffs Minecraft update. Let's get right into the video. So a new ore introduced in Minecraft in 1.17 was copper. Just like iron and gold and everything else, just copper is another metal that can be found in the ground in Minecraft. But what's special about copper is that Mojang enabled sort of a weathering effect. So as copper stays out in the outdoors more, it becomes increasingly weathered and goes from this bright red to this quite mellow aqua color here, as you might see with certain copper buildings, and especially the Statue of Liberty that used to be this bright vibrant red color as well and turned into this aqua. So here I've got my own model of the Statue of Liberty. Excuse the scale and the building quality, by the way. It's just an example, and we're going to see with a time lapse how this quite nice red structure turns into this not distasteful but certainly less attractive green. So we're going to set the random tick speed to 1000 because this takes a very long time, so we're just going to make the weathering effects 1000 times faster, and we'll set a nice little time lapse. So now we've left the copper here for a while. We have got this, all of that vibrant red copper has turned into this kind of weathered, what we know as patina, which is just a fancy word of saying oxidized copper. If you look inside here, all this solid copper has turned to this aqua color. Now I'm sure you're wondering, why is this the case? Well, it all comes down to ionic chemistry. That is, the reaction is when you have a metal and you react it with a non-metal. So in this case we have copper, and then we're reacting it with the air. So we know that the air is not entirely composed of oxygen, but that is going to be what definitely weathers this copper. So I'll just turn this tick speed down. So when we have our copper exposed to the air, the electrons in this copper are going to be starting to be attracted to the nucleus of these oxygen atoms, and when that happens, we're going to be forming a compound. So that, of course, both the copper ions and then the oxygen ions come together to form an ionic compound. And that just so happens that this ionic compound is this nice green color here. So that is how oxidization works. It's just a reaction with copper and the oxygen present in the air, and that air is of course exposed on the surface of this copper. So our next example here is going to be exploring lightning, and yet again referring to copper, we have in the game now what is called lightning rods. Now before we start, I think it's important to understand what lightning really is. So these clouds on a stormy day, we've got these huge clouds rubbing together and forming static charge, and we're building up a static charge in these clouds, and lightning is the discharge of that static charge. So we've got a point on the ground that this charge is being, or this energy is really being deposited to, as we can see there right on cue. And you'll notice when you have a thunderstorm, lightning often strikes in at tall places. When we don't have these lightning rods, it can be quite random because we're just in a forest here. Not a lot of overly tall points, and that is because it's just finding the best way to get that energy down to the ground as fast as possible. But if we have copper, which is one of the most conductive metals known to man, we're going to create a much more efficient path down to the ground for this static discharge to be essentially flown to through the air. So copper, extremely electrically and thermally conductive metal. So it's just a matter of time before we get a lightning strike on one of these copper rods. So that was out. Well, yep. So it's definitely firing up now. So as we can see, instead of striking a random point around here, our lightning is actually getting directed straight onto these very conductive rods, essentially providing the path of least resistance from this charge built up in the clouds down onto these copper rods. So yet again, Minecraft has done a good job with keeping the science quite accurate here. Okay, so our final example here is dabbling in a bit of geology. So in the new update, there is a rock called deep slate, found at low levels, and ores, of course, can be found in deep slate as well. The main point being, deep slate is based off the rock in the real world known as slate. Slate is a metamorphic rock, which means that it is actually made through heat and pressure of different other rocks known as shale and other minerals, of course. But when these other rocks are brought together at such low levels and with such high temperature and pressure from the Earth's magma, they are pressed into what we know as slate. Now, the parallel layers seen in slate is from the immense downward force of thousands and millions of tons of rock above. That is why you'll see very strong strength along the grain, but not as strong against the grain because of these parallel formations as seen with deep slate here. That's it for this video, guys. Thanks very much for watching. Hopefully you all learn about some different kind of science concepts using the new Minecraft update. I'll see you all later.